syllabus. Today I am not taking too much of the syllabus because we are going to have almost only the three circuits we are going to study: single acting, double acting, and regenerative cylinder circuit. Okay, we will look into, and we will not take more than an hour. Okay, that's it. By 11:15 we'll wind up. Okay, so let me go back to that PPT. Is it visible?
Yes, sir.
Okay. Yeah. So in the single acting cylinder, what are the specific features like? Only one side of the piston is supplied with the uh, hydraulic fluid. So the fluid enters the blank end of the cylinder. Okay. So you can see that here the entry of the oil is represented by this port A. So it has the rod end. Rod end means this entire space which has this hydraulic piston rod, okay, which we call it as a rod end, and this left side we call it as a blank end, because this complete area is available for filling of the hydraulic fluid. So we represent the cylinder or the movement as oil entry into the blank end and oil entry into the rod end. Okay, so you can see only piston side is supplied with the hydraulic fluid. So here we enter, the oil enters here and pushes this piston ahead. Only works in one direction. So the direction of movement or the hydraulic fluid which is entering performs the work during extension. Retraction is by spring action if it is a single acting spring operated cylinder. So the return stroke affected by the spring or the load. Okay, so there will be a spring here which will retract. It will be compressed during the extension, and it will get expanded during the retraction stroke. Okay, then what are the applications of this single acting cylinder? One is lifting, and second is clamping and moving the workpiece. These are the three applications. Now, if we have the single acting cylinder, what about the other elements of the hydraulic system? That we call it as a hydraulic circuit, which we can see over here. Okay, so how is the operation of this single acting cylinder? Okay, this is for a double acting cylinder. Fine. So 1 second, for single acting cylinder I'll show you. Give me a minute. Okay, are you able to see this? So this is a single acting cylinder circuit. So what might be the questions that they may ask you in this unit is: sketch and explain the working of a single acting hydraulic cylinder. Sketch and explain the working of a double pump hydraulic system, and so on. Sketch and explain the working of a regenerative cylinder circuit. So having that question, you are supposed to draw this entire circuit diagram starting from the reservoir, the filter from which the oil is filtered, then we have the pump. Okay, then we have a PRV that is connected over here, pressure relief valve. Okay, this entire circuit diagram is not to the scale. Okay, it is randomly drawn. Fine. So we have the pressure relief valve, then we have this directional control valve. Can anyone name this DCV? Come on, name this DCV. Just observe. And how will you name this DCV? I'm waiting for your answer. Yes? Anyone?
Sir, 3x2 solenoid actuated pump.
Okay.
Direction
3,
control valve.
3 by 2 is correct. Is it solenoid actuated? Yes. Then one more word you missed. Okay, so let me tell you, it is 3 by 2. Okay, why 3 by 2? Because 3 ports are there, the fourth port is missing here. 2 because one position, second position. Then next is solenoid valve, solenoid actuated, okay, spring retracted, manually controlled DCV. See, your actuation is by manual push button. Okay, so this part you can leave. So how will you define it? How will you name this? It is nothing but 3 by 2 solenoid actuated spring retracted directional control valve. Okay, so please remember this: 3 by 2 solenoid actuated spring retracted directional control valve. Okay, so this is how. So this can be a kind of a quiz questions we may ask you. Name the DCV, you have to write it correctly. Okay, so 3 by 2 solenoid operated spring retracted directional control valve. So from this you have two envelopes. Okay, then the connection is for the blank end of the cylinder, and you can see a spring has been fixed over here, correct? So this spring will get compressed during the extension stroke, and during the retraction stroke it will automatically come back to this position. Okay, so this is how the single acting cylinder construction or the circuit construction is. Now let us see how the working is. You are supposed to explain the working for each of these circuits in during extension mode and during retraction mode. So let us understand. Oil from the reservoir is filtered and pumped to the DCV. So in the present mode, what is this present mode? Is it extension mode or retraction mode? Can anyone tell me? Let's make the class little interactive. Otherwise, it will be one way. It was one way till now. Tell me, is it in extended mode or retracted mode at present?
Retracted mode, sir.
Retracted mode. Perfect. So in this, what is happening at present? The oil during retraction, what has happened? All the oil which was collected during the extension in the blank end of the cylinder has been diverted back through this port or through this connection A to T to the reservoir. Okay, so you can see this line here. So this is P, this is T. Okay, I hope you remember. P is nothing but the pressure line from the pump. From the pump P to the tank T. And what are these two ports? A and B. So you remember that. P to A. Okay, and T, B to T. Okay, A, B are these two, and these are P and T. Here B is missing. Okay, port B is missing. So when you want to extend the cylinder, what they will do? They will manually push this button. Okay, this button, there will be a lever. If you pull the lever, what will happen? This envelope will get connected over here. So what will happen? Oil from the pump will be pumped from the port P to A, which will enter the blank end of the cylinder. It will push this piston, compresses the spring, complete the extension stroke, and then once the extension stroke is completed, it will be held in that position. At that time, what will get actuated? Can you tell me? After the end of the extension stroke, tell me what should get actuated? What valve should get actuated? Yes, please.
Sir, left side wall, that is direct control. This is direct line from reservoir to the cylinder.
No, 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 no. So after the complete extension of the cylinder, this section will get actuated. Pressure relief valve. I hope you remember. See, this is how we are connecting from last chapter to this chapter. You people have studied pressure relief valve. So what is the pressure relief valve function? You have to reduce the pressure when it is at the end of the extension stroke or at the end of the retraction stroke. So I had explained you during my explanation of PRV that Once the extension is completed, the pump will be on. If you remember, even in our during our experimentation, pump will never be off. You remember that once the extension is completed, we start explaining to you some bits. Till that time also, at that time also, pump will be on. But where is the discharge of the fluid? The pump will try to push some more fluid here, but this extension is completed. So what will happen? Pressure will rise in this pilot line here. Can you see the pilot line? So since the pressure rises in this pilot line, what will happen? This lever will get connected here. Okay, it will get connected and the pump unloads to the tank via the pressure relief valve. Is it clear? So this is the function of your pressure relief valve. This control component is very important here. Similarly, at the end of the retraction stroke, after complete retraction has happened, what will happen? All the oil from here has been drained back to the tank, but still the pump is on. Till the next extension starts, the pump will be on. It will not be off. Okay, so it will be unloading to the tank via the PRV. Did you understand this logic? So this entire circuit diagram you are supposed to draw in the examination. It may be asked for 6 marks or 10 marks. Sketch and explain the operation of a single acting cylinder. So you are supposed to draw this entire circuit diagram and name everything here. Name the DCV, name the PRV, then name the cylinder, okay, and do all the namings and then explain during extension what happens, during retraction what happens, and also you have to mention the function of a pressure relief valve. Is it clear? Any doubts in the circuit?
No, sir.
Fine. So this is how you are going to draw the sketch and explain. And you are going to draw only line diagrams in the examination. So need not worry about it. These are all line diagrams, okay? Two-dimensional drawings, okay? Wherein you are symbolically representing these things, fine? And not to the scale. You need not you need not have the scaling, but you have to use the scale. Please remember. Don't draw these boxes with freehand drawing. You will not get marks. You must use the geometric instruments, but don't measure anything. I am not telling that this should be of this centimeter or this should be of this centimeter. It should be proportional, okay? So generally your actuator will be the largest compared to all other elements. Here the PRV is slightly larger, not necessary. DCV also it can be small, okay? But actuator will be large. Is it clear? Okay, so this is how you have to explain the complete operation of a single acting cylinder. One diagram which will carry 4 marks and the explanation may carry 4 marks. In that 4-mark explanation, 2 mark for extension explanation, 2 mark for retraction, and 1 more mark if it is for 10 marks, then last 2 marks carry for the functioning of the PRV. You have to explain that. Is it clear? Now, let's go to double acting cylinder. So this is, pardon? Yes, spring retraction. So let's go to the double acting hydraulic cylinder operation. So the same circuit diagram you can draw. Come on. Now, how do you analyze the working of a double acting hydraulic cylinder? Okay, this is the load that it has to carry. Okay, and it will perform some operation. Now, how the explanation for your answer should start is same thing. Oil from the tank is filtered and from the pump it is passed through a check valve. Here you can see this is a check valve, fine. And then what will happen? It will be unloading to the tank in the what do you call in the central envelope. Can you see the central envelope? Okay. Now come on, let's name this DCV. How do you name this now? Tell me. Someone else can try. Name the DCV. Analyze how many ports are there, how many envelopes are there, and what are the control elements for this DCV. Come on, I'm waiting for your answer. Can anyone?
It is same, sir. 4x3 solenoid spring actuated DC.
No. If you write this, it's wrong. It is not spring actuated. It is.
Toggle.
Is it solenoid valve? Can you check and tell? Is there solenoid actuation there? No. I don't see any solenoid actuation. Manual actuation is there.
So toggle operated one.
Toggle operated. Okay, that manual operation may be through toggle or whatever it is. That's fine, no problem for me. But how you will define this? How you will name this? So first,
So
what you
you
have
mean
to.
to say the path of flow of fluid?
No, 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 no. I mean to say only name the DCV. Still, we are still in this. Only the DCV. Just name the DCV. Because in the examination, like in the quiz, we will give you this diagram, okay? And you have to name the DCV. You have to understand, like, how can you name this DCV? So let me go back to this single acting cylinder and once again explain you how did I decide the name of the DCV. See, first thing what you say 4 by 3 or 3 by 2 or 5 by 2 or 2 by 2 and so on, correct? So this is what, how many number of ports are there in this? Port 1, port 2, port 3. So you name it as 3. Then how many envelopes are there? Means how many positions that DCV can help in taking. One position is this, that is extension, and one position is this, that is retraction. So 2. So that is why it became what? 3 by 2. Next comes how it is operated. It is lever operated. Okay. Now, or lever operated during what? Extension means this push button is there. But during retraction, what it is? It is spring return. Fine. And there, here it is written that it's a solenoid valve. There is a solenoid valve. So you named it as what? 3 by 2 solenoid actuated spring retracted directional control valve. Okay. Fine. So like this, let me know how you can name this. Come on, let me help you all in doing this. Tell me how many ports are there in this?
4 ports.
4 ports. If you check any envelope, central envelope, this is extension envelope, and this is retraction mode or retraction envelope. Okay. How many are there? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. In each envelope, whatever port is there, that is the final. Okay. So 4, sorry, ports, number of ports, 4 ports slash 3 envelopes. Here it was how many envelopes? 2 envelopes, only 2. The extension and retraction, only those 2 were there. Was there a neutral or central envelope? No. Now it is there. So that is 3 by 2. Now what position is this DCV in actually? It is in center position. Central envelope is actuated, right? So how it is kept in that center position? By these 2 springs. So how you can name it? Spring centered. It is spring centered. But how is the actuation here? Can you see both the sides what are there? Manual levers are there. So you can name this DCV as 4 by 3 spring centered manually actuated directional control valve. Is it clear? Okay. So presently you are in center position. That's why that word I told you, spring centered. Okay. Normally it will be in the central position and there will be hydraulically locked. This entire system is hydraulically locked. Means there is no flow inside this blank end. There is no flow outside this rod end, nor there is a reverse flow. Nothing. It's just in off position. Off means actuator is off. But still the pump may be pumping the fluid. But in that case, what will happen? It will directly go to the tank at this present position. Now, did you understand how to name the DCV? Now, let me tell you regarding this, how you are going to have the operation. So, after drawing the circuit diagram, please name this actuators also. Here, the few namings are missing. All namings are missing. You have to name it in the exam. Okay. So in the extension mode, which is the extension mode? This mode. Okay. The arrows are not clear here. Actually, there is an upward arrow here and there is a downward arrow here. Similarly, here also one arrow, second arrow. You have to draw that arrow. Please draw that. Okay. You have drawn this during your lab experiment.
Excuse me, sir. Sir, mouse pointer is not visible.
Okay, because both are white. The background is white and this, what is that? Our mouse pointer is also white. That's fine. Don't worry. So you are supposed to draw the arrows. You know that upward arrow in the left envelope and a downward arrow in the right envelope. Okay. So let me just explain to you the working of this. So how you are going to explain? You are going to explain it in 3 bits. One is neutral position. At present, it's in neutral position. In neutral position, oil from the tank through the filter, enters the check valve and is drained back to the tank through the regular connection. Port A and port B both are inactive. There is no flow of the oil into the actuator. This is your neutral envelope. Now, during the left or during extension, you can mention like this. During extension, the left envelope is actuated, in which oil from the pump enters the port P. From P, it enters to port A and enters the blank end of the cylinder, and it pushes the piston. But please remember, oil is also present in the rod end of the cylinder. The entire hydraulic system is filled with oil. So what happens to the oil that is present in the rod end of the cylinder? It will start moving back through the connection B to T. Correct? So this upper one will be B and T will be the tank. You can see here from B to T, it will drain back to the tank. This is the complete extension. Okay, like this you have to explain. Similarly, let's go to the retraction. How the retraction mode is actuated? By pushing this right side lever. Okay, you have the knob, no? You do it, right? You do it in the lab, fine? So during the retraction mode, oil from the pump enters the port from P to B. Can you see this cross mark? Okay, there is a cross mark during retraction. So oil from P, from the pump, enters to the port B first. So what will happen? Oil will start entering in the rod end of the cylinder here. So that pushes the piston back from the extreme right side. It starts pushing the piston back here. What will happen? Then oil which is present already in the blank end of the cylinder, which was earlier filled during extension, what happens? That oil will start moving out from connection A to T. Okay, that is why it is downward arrow. So this is how you can explain the retraction of the double acting hydraulic cylinder. So generally when you go through these kind of circuits, you have to explain it in 3 bits. Why 3 bits? Because there are 3 envelopes which will get actuated. So the first envelope is the neutral mode or neutral position. Second envelope is your extension, and third is your retraction. So let me explain once again. You can explain it in your own words. However, the technicality should not be lost. Okay. So how we will explain? During the neutral envelope or neutral position, oil from the pump enters the check valve and drains back to the tank. Fine. Next, during the extension mode, oil from the pump through the check valve enters the port A, enters the port P. From P, the oil moves to port A and enters the blank end of the cylinder. The oil present at the rod end of the cylinder is drained back to the tank via the connection of port B to T. This is your extension explanation. Next paragraph you can write retraction explanation. During retraction, when manually operated, okay, for the retraction mode, oil from the pump oil from the pump enters from the port P to B and enters the rod end of the cylinder, which pushes the piston, and the oil present already in the blank end of the cylinder connects to the port A. From port A, it is drained back to the tank. This is your retraction mode. This is how you have to explain. Now tell me, what is the function of PRV then? During extension we understood, during retraction we understood, and central we understood. What is the use of PRV now? Again, you have to write one line about this PRV, right? You cannot neglect it. Can anyone tell me?
Sir, after complete extension or complete retraction of the actuator, the pressure in the system rises and that will be released by PRV.
Perfect. That is the reason, right? So this one statement also you have to write in your answer. If you neglect this statement, then 1 or 2 marks of the same will be deducted, because this circuit will be asked for 10 marks. Sketch and explain the working of a double acting hydraulic cylinder. For 10 marks, 4 marks will be for the circuit diagram, 2 marks for extension, 2 marks for retraction, and 1 mark for central position and 1 mark for this PRV function. So don't leave anything in your explanation, and please write them point wise. Okay. So most important is in your circuit diagram, you have to specify the components. This is DCV. Don't write only DCV. We want the name of the DCV there. Okay. So that is why I am highlighting how you have to name these DCVs. Similarly here actuator. In that actuator, right, this is piston, a rod, and this is the blank end and rod end. Because we are using these words in our answer explanation, right? That is the point. So you have to write here blank end, sorry, this side blank end, this side rod end. Similarly, these all elements have to be defined. Here you write PRV, here you write pump, filter, tank. So all the elements you are supposed to name it. Is it clear? Did you understand single acting cylinder and double acting cylinder both? Now just we'll quickly go through the difference. Here one more diagram of single and double acting. That's what I was telling. In the earlier diagram, arrows were missing. Here we have the arrows. So you can understand P to A, B to T during extension, and sorry, 1 minute. Yes. So one more important thing I wish to tell you. Here the connections, if you see, the arrows are not complete. Okay. You have to complete these arrows. You have to join them. Okay. Correctly you draw. Don't leave any gap here. Fine. So P to A, B to T. Similarly here, P to B and A to T. So this is solenoid valve. If you use a solenoid valve, then we call it as a solenoid actuated. If you have two springs, now in this diagram there is only one spring, correct? So you can call it as solenoid actuated now. If it is not solenoid actuated, then it is spring centered as in this. Is it clear? So let's see the difference between the single acting cylinder and double acting cylinder. Just for your understanding, I have put this slide. Just go through. It has one port, it has two ports, it has a spring, this does not have a spring. Now this spring doesn't mean that spring centered DCV. Spring means that inside the cylinder for that piston retraction, is there any spring? No, we don't have any spring in double acting cylinder. In single acting we have. Next, here single acting cylinder exerts force in one direction only. Here it exerts force in two directions. Why it exerts force only in one direction? Can anyone tell me? And not in the other direction? What force comes into action in single acting cylinder during retraction? Yes, please.
In the rod end side, whatever oil will be present, that is directly drained back to the reservoir, and which during the retraction stroke spring is activated.
Correct. So
Single
the
acting
spring
cylinder.
force acts and no force is applied through the hydraulic fluid. Okay. So what does that mean? Can anyone tell me? Is there oil at both the sides in single acting cylinder or at only one side? Is there oil that is available or present in both the sides or only one side?
One side, sir.
Yes. Which side? Blank end or rod end?
Blank end.
Blank end, correct. So there is no oil in the rod end of the cylinder. So please remember these kind of questions which we may ask, okay, in the quiz. Okay, next. Here he has written with regards to the pneumatic also. So that is the fourth point. It uses compressed air in the forward stroke while return stroke is achieved by spring. Instead of compressed air, we use hydraulic fluid, okay, because it's pneumatics. Then here it uses compressed air both in forward stroke and backward stroke. So you don't worry about the compressed air word. You remember that it is hydraulic fluid. So hydraulic fluid is used at both the sides in double acting. Okay. Yes. So Srinidhi sir has a question for you all. Okay. So just you can here. Any other doubt with these two cylinders? Yes. Any doubt?
No, sir.
Okay, 1 minute. Srinidhi sir has a question and then we will break for a small break and single acting. Okay.
Question actually yeah, guys, can you hear me?
Yes, sir.
Okay. Can you see the DCV of the single acting cylinder?
Yes,
Yes.
sir.
Yes, sir.
In normal position, which port is getting connected to which port? Piece getting connected to A, And T is okay. P is getting connected to A in normal position, correct? Okay. Now let's go to double acting cylinder circuit. In center position, P is getting connected to T. When you go to left envelope, P will go to A and B will go to T. When you go to right envelope, P will go to B and A will go to T. This is the connection. Now, my question to you is, can I use this 4x3 valve, which is there in this double acting cylinder, for a single acting cylinder? If yes, how? If no, why? Getting the question? This same DCV that you see in the double acting cylinder circuit, can I use this in a single acting cylinder? If yes, how? If no, why? I hope you're understanding the question.
No, sir.
We cannot use it. Why?
Because at the rod end side, there will not be any oil in the single acting cylinder. So at the left envelope, they will be cross connected. So there may be
Okay.
leakage.
I got your answer. Fine. Anyone else would like to respond?
So we can use this, sir, by connecting B port to the tank and A port to the inlet of the actuator.
You are going slightly in the other way, opposite direction. Okay. Any other attempts? Because I'm okay, fine. Because I'm using a headphone, Harshit sir probably couldn't hear what you said. Sir, their first answer was they cannot use it because in the when P gets connected to B port, oil will not go there because there is a spring in the single acting cylinder. The other answer was we should connect the P port to A port and P and T will become A and B. Ulta. A and B port. Andre ulta hatsudad. Keಳಗಿನ ಮೇಲೆ ಮೇಲಿನ ಕೆಳಗೆ ಮಾಡೋದು. But second answer is okay, but reason is not valid. I'll tell you what to do. If you want to, now there are applications. See, many times what happens is in an industry, you cannot afford to go for 3 or 4 or 5 pumps for different applications, correct? So what do? You use only one single pump and you connect many circuits over there. So even in this circuit, when you see this tank and a strainer and a pump is going to that pressure relief valve and then it goes to the DCV. At this point, there will be branching. There will be many number of DCVs. So one single pump will be supplying oil to n number of circuits. So branching will be there just before the PRV or after the PRV. Now what happens is, and also there's no hard and fast rule that the normal position should be like P is getting connected to A port for a single acting cylinder, or the normal position should be P is getting connected to T. All flexibilities are available. So if I want to use this same DCV for single acting cylinder, what I'll do is I'll plug the B port. That means I'm going to block the B port. Okay, I'll not do anything else. I will only plug the B port. That means using a plug or any blockage, I'll just block it. So when I block it, what will happen? 4 port got converted to 3 port. Correct? Instead of 4 ports, now you have P port, A port and T port. P is blocked. Then there will be still 3 positions. Okay. In first position, what happens? In the center position, P is getting connected to T. All the oil will go from pump to the tank port. Not a problem. When you operate the left lever, when you operate the left envelope, P will get connected to A port. So oil will go from pump to P port to A port to the blank end of the cylinder, and the cylinder will start extending. Once the cylinder is totally extended, additional oil which is flowing into the circuit will go through the pressure relief valve back to the tank because the cylinder is fully extended position. Now when I operate the lever on the other side and bring it to the right envelope, there what will happen? P will get connected to B port, but B port is blocked. So oil will again go to pressure relief valve and then back to tank. A will get connected to T port. So oil from the A port will go to T port. That means oil from the blank end will go to the tank, because in single acting cylinder, the other side there is a spring. It will push the oil back to the tank. So I can use a 4x3 valve for a single acting cylinder by blocking one port and making it as a 3x3 valve. By making it as a 3x3 valve. Similar, if you go to earlier case where you had a 3x2 position valve, okay, There I can drill one more port and make it as B port, or instead of drilling, maybe it was already a 4 by 2 wall. We have just blocked the B port. I'll open that block, then it becomes 4. Single acting. In this, there is no B port. Now what I'll do, I'll open that block. So B port will be activated. So now what happens? By default, P will get connected to A and B will get connected to T. Oil will go from P port to A port into blank end, and from the rod end, it will go to B port and to the tank. And in other position, crisscross. So I can use this 3 by 2 wall for a double acting cylinder also, just by opening one more port in it. Okay. So if you're drawing a circuit diagram, whatever is displayed on your screen, this is not the only combination. This combination is shown to you for your easy understanding. Now, what examples that I told you over here of converting the 4 by 3 to 3 by 3 and 3 by 2 to 4 by 2, this all depends on application, cost, application, space availability, all those things. Right? Because if you go for a 4 by 3 valve and block one port and use it for a single acting cylinder, 4 by 3 is costlier. You may or may not be able to put extra money on it. So you may go for 3 by 2 wall. So this wall DCV that we are not talking, not only for these two circuits, for all the circuits that you're going to study henceforth, this is not the fixed DCV. You can use any type of DCV. It all depends on application, circuit space available for you, cost, and other factors. Right? So I'm just telling you an example how the things can be interchanged. Also, there is no hard and fast rule that when you go for left envelope, P should get connected to A port and B should get connected to T port. And when you go for right envelope, P will get to B and A will get to T. No hard and fast rule. You can interchange that also. When you go for left envelope, P can go to B and A can go to T. In the sense, when you go for left envelope, first retraction will take place, and when you go for right envelope, then extension will take place. You can exchange those position also. This is all depending on your requirement and application. Remember this one. So when you go for hydraulic circuit, there is lot of flexibility. So some guys takes a 4 by 3 valve and plugs in one port and take it as a 3 by 3 valve and use it for a single acting cylinder. I cannot say that his circuit diagram is wrong. His circuit diagram is also correct because it is going to work for single acting also. Only thing is he has made modifications in the port that he has. If I take one more example, now what happens suppose there's an industry wherein there is already a 4 by 3 valve with them and they want to control a single acting cylinder. But as per the study, single acting cylinder require a 3 by 2 valve. So instead of buying 3 by 2 valve, what an experienced guy or a logical guy or the intelligent guy will do, he'll just block one port of that 4 by 3 DCV and make it 3 by 3. Thereby what he did, he saved the cost of buying a new DCV and he is using the same one, existing one for the circuit. This also is possible. So keep your mind open for all such things. Is that okay? I'll hand in the, okay, is that okay?
Yes, sir.
Right. I'll hand in the mic to Harshit sir now, right? He'll continue.
Okay, so let us have a small break now. I have found a very interesting video. Once you are returned from the break, we will play that video. By 11:15, we will meet back. Okay, is it fine?
Yes, sir.
Yes,
Okay,
sir.
right, fine. Once. Hello? Am I audible? Hello?
Yes, sir, audible.
Okay. Now I am going to show you one interesting video regarding single and double acting cylinder application and working. Please go through. Okay. Just a minute. Just see if you are able to see this. Are you able to? Animation?
Yes, sir.
Okay. I'll just increase the audio. Okay. Confirm. Are you able to see this?
Yes, sir.
Yes, sir.
Okay. Is it audible? Or shall I increase the sound?
No, sir.
I have kept it now 100. Let me increase this sound. Yes. Okay.
Cylinder actuators deliver a linear push-pull motion via a rod and piston within a cylindrical tube. A single-acting cylinder is a cylinder in which the working fluid acts on only one side of the piston. The other side of the cylinder utilizes a mechanical load, springs, compressed air, other cylinders, or the momentum of a flywheel to push the piston back in the other direction. This particular cylinder utilizes a spring on the non-fluid side. A single-acting cylinder produces linear motion in one direction. When a control valve directs fluid through the inlet port into the blind end, pressure builds up and generates a force on the piston. When the pressure buildup is large enough, the piston begins to move, extending the rod. This is called the forward stroke. When a control valve directs fluid out of the port, the fluid pressure is removed. The force of the spring pushes against the piston in the other direction, and the rod returns to the cylinder. This is called the retraction stroke. Single-acting cylinders are most often found in reciprocating engines, pumps, and hydraulic rams. A double-acting cylinder is a cylinder in which fluid acts on both sides of the piston. This type of cylinder can produce linear motion in two directions. A double-acting cylinder has two fluid ports, one on the blind end and one on the rod end. A directional control valve sends fluid through the blind end port while venting fluid out the rod end port back to the tank. Pressure builds up and generates a force on the piston, causing the extension stroke. When the directional control valve is shifted, it sends fluid into the rod end port, out of the blind end port, and back to the tank. Pressure builds up and generates a force on the other side of the piston, causing the retraction stroke. To determine the speed of a piston during extension and retraction, we must first determine the significant working areas. The full piston area is the side of the piston without the rod. This is the area that feels pressure as the piston extends. The next significant working area is called the net area. This area is the size of the full piston area minus the area of the rod. The net area feels pressure when the cylinder retracts. The speed at which the piston extends and retracts is calculated using the volumetric flow rate divided by the area for the incoming fluid. Since each side of the cylinder has a different working area, each side experiences a different speed. Let's assume that the volumetric flow rate is equal for each inlet. Because the rod takes up space within the cylinder, less fluid is required to fill that side. This means that the fluid can fill the rod end side more quickly than it can fill the blind end. Since the rod end side fills with fluid more quickly, the cylinder will always retract faster than it can extend. All the cylinders shown to this point have been single-ended. They have only one working rod. On special cylinders, 2 rods may be used. These are called double-ended cylinders. They have 2 rods, both attached to the piston, and each coming through an end cap. Double-ended cylinders work similarly to single-ended, but are used when a constant speed is required for both the extension and retraction strokes. Since the flow rate is the same and the piston areas are the same, the speed for extension and retraction is also the same. Due to their simple design, cylinders are used more often than any other type of actuator for industrial applications. Although their motion is linear, it can be converted to rotary motion by levers, racks, and pinions, or other means, making them one of the most versatile types of actuator.
I hope you understood.
Yes, sir.
Yeah, this video links also I am keeping in the PPT, okay, so that you people can just go through once again to understand the concepts. Fine. One more minute, 2 more minutes. The regenerative cylinder circuit we will take it in the next class because I don't want to hurry up. Hardly we have another 2 more classes. Okay, so I have covered almost whatever need to be covered for 1 hour because tomorrow morning for the other 2 divisions, that is C and D, I am going to cover this much only, okay, so that no one should lag or lead ahead, okay. So just give me a minute, I'm checking something.
I have this question for you. What do you mean by learning public speaking skills? Is this
and their application, assembly lines,
I wish to
also
show
their
this
functioning.
one more video, okay. I just saw it. Is it visible?
Yes, sir.
Yes, sir.
Okay. Please go through this video
and
also.
their applications in the industrial sector. The common basic component used in these machines that converts fluid pressure to lineal actuated motion is the hydraulic cylinder. As diggers on construction sites,
You can see the
assembly
practical
lines,
applications.
but also industrial package machines. Before starting, it is essential to specify that there are differences between single acting cylinder and the double acting one. The single acting cylinder can be ruled in one direction only, and the fluid gas, which is spread by a pump or compressor, enters from one end only and pushes the stem out. To guarantee that it returns to its original position, the single acting piston is rejected by a spring integrated into the system. The double acting piston, differently from the single acting one, can be moved directly by the operator in 2 directions by sliding it back and forth along its axis. Consequently, there is inclusive control of the mechanical organ. This system is generally the most used for movement of many types of equipment, thanks to the possibility of full control of the same without being subjected to weighting or action of the control spring. Piston assembly shown here is the functional model of a hydraulic cylinder. It consists of a cylindrical bore with an end cap. Its function is to hold the fluid pressure when oil is pumped into the cylinder. A cylinder head is attached to the other end of the barrel. A piston rod extends from inside the cylinder through the head. It transforms the force from the cylinder to the equipment on which the cylinder system is used. A piston is attached to the piston rod. It splits the cylinder bore into 2 compartments and reciprocates back and forth when the pressure is developed on both sides of the cylinder chamber. A set of circular sealing rings are used in the interface of metals. The seals used between the surface of the metals in relative motion are dynamic seals, and those acting between 2 surfaces at rest with respect to each other are static seals. A piston seal acts as a pressure barrier between 2 chambers separated by a piston. The seal is used to wipe dirt from the rod while entering through the head and prevent contamination of oil. A rod guide ring is used to absorb transverse forces acting on the system and prevents metal to metal contact of the rod and cylinder head. Now let's understand the operating principle of a hydraulic cylinder. The model shown here is a double-acting hydraulic cylinder. In other words, this means that the system can extend or retract by using hydraulic fluid in both conditions. The hydraulic cylinder functioning is based on the principle of Pascal, given by B. Pascal, a well-known French mathematician who wrote the law of fluid physics in 1653. This law establishes that when an increase in pressure occurs at the point of the confined fluid, this increase is also transmitted to each point of the fluid inside the container with the same intensity. As we can see from the picture, a passage is created in the cylinder to allow the liquid to enter the chamber, which we will name C-A. Since the chamber is airtight, the fluid will exert pressure on all sides. The piston is the only moving part inside the cylinder, so when the pressure rises inside the cylinder, the piston will begin to move. At the same time, it pushes the liquid into the chamber C-B, which, exiting the cylinder, will have lower pressure. Here we can observe the hydraulic cylinder functioning on this digger. The cylinder is attached to the pump through some cables, which contain the hydraulic fluid. A control valve manages the introduction of the liquid into the cylinder chambers. The operator adjusts the pressure exerted by the liquid so that the cylinder piston can perform its linear movement in both directions. The operator can precisely control the digger arm from its position by simply increasing or decreasing the pressure in the cylinder chambers. The pneumatic cylinder is not much different from a hydraulic cylinder. Differently from the hydraulic cylinder, the pneumatic one uses, indeed, compressed gas instead of liquid. Pneumatic cylinders and actuators are an easy way to gain strength and generate.
The whole explanation is with regards to pneumatics, but if you replace that pneumatics by hydraulics, that becomes your by fluid, that is your oil, that becomes hydraulic. Okay.
Accurate linear and or rotary movement, and they can be used in harsh environments, even in extreme temperatures. Light and requiring little maintenance, they generally produce less force and a lower speed than hydraulic or electrical systems, but they remain an economically advantageous alternative. The key components of a pneumatic cylinder include end caps, a piston, a rod, a scraping seal, a guide, and sealing gaskets. Pneumatic systems use compressed air to create rotary or linear motion and power applications. The pneumatic cylinder will use compressed air to act on the piston inside the cylinder to create the required movement. For example, tightening or to move a load along a linear path. A double-acting pneumatic actuator or cylinder has two holes which allow pressure to be applied for movement of the piston in the opposite direction than the one created by the first outlet. Generally, larger is the cylinder hole and greater is the output in terms of strength. JAES, having been in industrial supplies business for over 10 years, has become the contact partner for some of the main companies belonging to the world of industrial mechanics and has offered a full range of hydraulic and pneumatic cylinders in its catalog. Pneumatic cylinders can be used in a wide range of applications and are particularly common in factory automation systems. This includes production, handling, and packaging of materials in which they are used to position or move parts or tools and carry out pick-and-place activities.
Okay, I hope these videos were really useful and you can make the best out of them. I will just click on the attendance, just a minute. Okay, so any doubts, any clarifications? Your test is next week, right?
Yes, sir.
Yeah, so any doubts with regards to that, anything? I have just now uploaded PPT on PPT for unit number 4, control components in hydraulic system. Okay, in that we have PCV and FCV. Another one, PPT on DCV, unit number 4, I am uploading immediately now. That is one thing. Second is the videos I have already uploaded. I hope all you people have gone through the video of last class and last to last class. Both I have uploaded. So just go through that. Fine. Anything else? And your test will be like there will be 3 questions of 12.5 marks each. You are supposed to answer any 2. Okay, so maybe we may mix like questions. There will be one question which will be mixed like FP and FV. Sorry, fluid power and fluid machines, both will be mixed up. Okay, any other doubts? I have posted the DCV PPT also, and in another share I have posted the PCV and FCV. Both PPTs I have posted, and see to it that you also refer the syllabus and once again check everything what all is there, and if anything is missing let me know, or you can do it. Fine. Any other doubts? Fine then. Let's close the session for the day. We will meet next week, because I think next week you have IAs. We will not have any classes next week. Okay, we don't know how it will be. Okay, fine. Thank you.